going a slightly different direction. Okay, this whole chapter has been about quadratics, right? We threw in the i's, the imaginary numbers, but we still dealt with solving quadratics and all of that entailed. Today we're looking at solving systems of equations, which we did back in chapter 3 maybe? Whatever chapter that was. We solved systems of equations. But when we solved systems of equations, it was always 2 lines, 2 linear equations. And we practiced graphing, and we did substitution, and we did elimination. Today, we're doing a little bit of all of those. But today we're talking about when it's not 2 lines, but it's a quadratic and a line. So a system of 1 quadratic equation and 1 linear equation can have 2 solutions, 1 solution, or no solution. And so I want to look at those possibilities. So the idea, realize when I say quadratic, what's the shape of that graph? Quadratic is the U shape, the parabola, yes? When we talk about linear, we're talking about a line. So this first picture is an example of when there can be 2 solutions, because a line could cross through a parabola in 2 spots, yes? Okay. This next one is an example of 1 solution, where the line just touches the parabola in 1 spot. And this third example is an example of no solution, where the line and the parabola will never cross. Okay, those are your 3 different types of options. We're just looking at a few basics today to get you guys the idea. I'm not putting a lot of emphasis on this lesson, but I'm not doing my job as an Algebra 2 teacher if I don't at least introduce it and, show you a little bit about it, okay? So, the example 1 is solving this by graphing. What's the idea of graphing? When we're trying to solve a system of equations by graphing, we're going to graph one, graph the other, and then with the idea of looking for where they intersect, right? So, with that in mind, the first one is a tough one. How do we graph y equals x squared plus 6x plus 9? How do we graph these? Which, by the way, this is the first half of the chapter that you're going to test on. I knew as soon as I closed the door. So. Okay, what are you thinking, Lorna?
I mean, you could use what the basic parabola is and multiply that by 6. And then the y-intercept would be 9.
I do agree the y-intercept is going to be 9 because that's my c value. But because there's that x term here, it's not multiplying it by 6. If it was 6x squared, we'd talk about it like that. Okay? So what I'm going to encourage us to think about, folks, is, and I'm going to bring this out. I'm trying to think how I want to set this up. I'm going to bring this out here. Y equals x squared plus 6x plus 9. Because there's that x term in the middle, we can't just go, okay, this is a parabola with a basic 0, 0 vertex. We have to find the vertex. Which means before we find the vertex, we have to find the axis of symmetry. Dig deep in those brains, or in those notes. We have a formula for an axis of symmetry.
Oh,
it's also on that gold paper. X equals negative b over 2a.
Yeah.
Goes back to probably about lesson 4.2. Yeah, guys, you have to be able to graph these on the test next week. I know, we've slept a lot since then. So, negative b over 2a. Negative of, what's b? 6 over 2 times, what's a? The invisible 1. So, negative 6 over 2 times 1 is 2. Negative 6 over 2 is negative 3. So we have an axis of symmetry at negative 3. Then, what do we use that axis of symmetry to find? Plug it in, and it's going to help me find my vertex. I hope this sounds a little familiar, folks. Right now, I know my vertex is negative 3 comma something, because the axis of symmetry is that first number in the vertex, right? So, plug the negative 3 into the original problem. So it's going to be negative 3 squared plus 6 times negative 3 plus 9. Negative 3 squared is 9. 6 times negative 3 minus 18 plus 9.
0.
9 minus 18 plus 9 is 0. And so now we have a vertex of negative 3, 0. And then, if you recall graphing this, because we graphed these on the quiz, axis of symmetry, vertex, and we need one other point. And the one other point I kept encouraging you guys to do is your C value, which is your y-intercept. Remember, your y-intercept is always your C value there. Okay, what do you think? Can we graph this?
Yeah.
Now, axis of symmetry, x equals negative 3. So I'm going to go left 3. And when you are expected to draw the axis of symmetry in, it's just drawing that dotted line in. And then a vertex of negative 3, 0. Says my vertex is right there. Okay. And then we have a y-intercept of 9. Where's that at? I have a y-intercept of 9 there. What do you know? If this point is 3 to the right of the axis of symmetry, we have an equivalent point 3 to the left of the axis of symmetry. Does this sound at all familiar?
Yeah.
Dig deep, guys. I promise I've taught this. We've quizzed over it even.
Yeah.
Yeah. Okay. Now, one other thing you can think about doing. This is a 1x squared, isn't it, out front? And when your a value is 1, do you remember that the basic, when it's y equals x squared? And this is as long as a is 1. You can use the idea that from the vertex we have 0, 0, 1, 1, and 2, 4. That works as long as you have an a value of 1 and you know your vertex. We can do that. And I mention that because it's going to kind of be important here that, so from my vertex, where am I going to have points? I'm also going to have points that are 1 over, 1 up, and 2 over and 4 up from the vertex. Now, I just want to mention that because I'm going to be looking for where these lines intersect, and I know a little bit about where this problem goes, but okay. But there's your parabola, yes? Not the best drawing on the right side there, but okay, that's pulling all the information we know together about parabolas. we also have to graph y equals x plus 3. So now you need a totally different part of your brains for y equals x plus 3. What is y equals x plus 3 the graph of? Yeah, it's a line, isn't it? Thank you. Y equals mx plus b? That was earlier chapters this year, wasn't it? So, if we're talking y equals mx plus b, 3 is my y-intercept, and what's my slope? That invisible 1, right? Which I agree. 1 over 1 as a fraction. And what's our phrase for slope? Ah, there we go. Rise over run. She says those words and they sound familiar, right? So, start by doing your y-intercept of 3, which means I'm going to count up 3. Then we do our slope of 1, which means I'm going to rise 1, run 1. Rise 1, run 1. Except rise 1, run 1, I'm kind of going the wrong direction, aren't I? So what also can I do? Down 1, left 1. 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 Yes, I went overkill. But did you see some intersection points?
Yes.
You should have. How many did you come across?
2.
Should be 2.
I get 3.
Should have come up with 2.
Oh yeah, there's only 2.
Okay. And so remember, we need to state those intersection points because that's our solution here, right? So, I'm just going to write through here. What intersection points did you guys find? Is there definitely one right here at the vertex? I went through that vertex with my line. So one of my intersection points is the ordered pair, -3, 0.
-2, 1.
And then there's also one right there at -2, 1. Again, can't remember if I put any of them on of graphing on there. I mean, in homework, if it's graphing, keep in mind it's Math Excel, you're going to be looking at the graph, right? So it won't be necessarily, I can't remember if I have you that you have to graph any. But again, should you know how to graph this stuff? Technically, yes. Definitely y equals mx plus b. That's full out algebra 1 and earlier this semester algebra 2. Parabolas, that's this chapter, right? Okay. Questions on this? Hunter, are you still with me?
Yeah.
Sit up so I know you are, please. Okay. You got the graphing out of the way. Are you happy? Happy to be moving past it? I know some of you. Some of you are saying, yeah, I'm happy to be moving past it, but...
I got 1 and 6. You said the first was the hardest one?
Well, the graphing is the one I usually get the most struggle with. That's where we tend to be weaker is our graphing. Because we tend to have a dislike of it, so we tend to be weaker at it, right? So, okay, the bottom two, notice it says solving a linear quadratic system using substitution. And I know some of you are going to say, oh, I prefer elimination. No. But actually with this, substitution is the better route to go. Okay? Now, with the idea with substitution is you want one of your equations solved for x or y so that you can then plug it into the other equation. Well, what do you notice about both equations here?
They're both set to 1, so technically you can use either
Okay, they're both set equal to y, so we can use either one. So realize what's going to happen with these two equations, basically. If they both equal y, they're going to equal each other, right? Does that make sense? And you can think about it either way, but like this, if we look at this top one, y equals x squared minus 3x minus 20. That's y equals, so where can I plug it into? The y in the other equation. So if I plug that into the y, I have the equation x squared minus 3x minus 20 equals negative x minus 5. Okay, our job is to solve this equation. We've done this more recently.
You have to add the
I didn't catch what you said.
don't you have to add the 20 to the other side and same with the x squared?
Yeah.
I added the
Well,
5 over.
And here's what I'm going to say. I see x squared terms, I see x terms, and I see number terms. Since I have all three, I probably want to make this equation equal to 0. Because I have x squareds and x's. If I had just x squareds or just x's, I'd solve for that. Because I have both, I want to make it equal to 0. How can I make this equation equal to 0?
Subtract 5 or add 5 to both sides.
Okay, if there's a minus 5, we're going to add 5. And if there's a minus x, add x. And I'm going to do this all at once. I don't like taking multiple steps to do that. So now I have x squared
Minus 2x
minus 3x plus 1x is minus 2x.
minus 15
Minus 20 plus 5 is minus 15
equals 0.
equals 0.
Yay.
Yeah, I really keep you guys.
This should be more familiar than the graphing, though, because this is definitely more recent. We've got that equation equal to 0. What are solving options once you have an equation equal to 0? We are going to really cross our fingers, hope, and pray at factors, right? So when she says factor, it's x squared, which means we can go 2 parentheses. X squared breaks into x and x. How do I fill in those numbers?
5 and 3.
Okay, I agree. But it's going to be a product of the c value. So product of negative 15. So what multiplies to be negative 15? And a sum of negative 2. So I need my numbers that multiply to be negative 15 and then add to be negative 2.
5 and 3, which 3 is positive.
I say it is some combination of 3 and 5. If 3 times 5 has to multiply to be negative 15, one of these numbers is negative.
Always.
If I wanted to add to be a negative 2, larger number is negative. So we're going to have an x plus 3 and an x minus 5.
Are you going to set multiple equal to 0?
This is the no-brainer part, right? Once you have each factor, you set each factor equal to 0. So x plus 3 equals 0. X minus 5 equals 0. So if it's x plus 3, subtract 3, x equals negative 3. If it's x minus 5, add 5, x equals 5. Am I done?
No, there has to be another part to it.
I'm curious. Why do you say there has to be another part to it?
Because if you did that, it's just like the other lesson we did.
Okay. You feel like it has to go farther because there's more to this?
Yeah.
Plug
Okay.
it. We have it.
If you look back to the graph problem up above, what type of answers did I have?
2.
Ordered pairs? I had 2 ordered pairs, yes? When we solved systems of equations previously, whether it be graphing or elimination or substitution, we had one ordered pair. Today, you're often going to have two ordered pairs. Okay, so go back to the screen I'm on. What do we know about our two ordered pairs right now?
They both X's.
We know one of those ordered pairs is -3 comma something. And we know the other ordered pair is 5 comma something. How do I find the something, aka the y value?
You plug
You plug
it
it in. Where?
to the X.
To the y equals -x minus 5.
Do both.
You get a choice.
Oh.
You get a choice. You can go back and use either original equation. You can use the y equals x squared minus 3x minus 20, or you can use the y equals -x minus 5. Your choice. Meet me at the end, right? It doesn't matter. It'll work out the same. I tend to use the linear equation. So I'm going to use y equals -x minus 5. And I'm going to plug those values in. So I'm going to say y equals -x minus 5. So I'm going to say the negative of -3, 3 minus 5. And what is 3 minus 5? -2. What do you know about that -2?
It goes with your negative.
It completes the ordered pair with the -3. Then repeat the process. Negative of x, so negative of 5 minus 5. -5 minus 5? -10. Where's that -10 go? With your 5.
Oh, that's
Better than the graphing part, right?
yeah.
I knew you guys would like this part better. Thus, I had to do the graphing first.
The graphing wasn't bad.
Okay? And this is more, what I want you guys to be responsible for. Just realizing, okay, yes, we can do substitution. Oh, hey, we know how to solve a quadratic. We can get equal to 0. We can factor. Just realize when you get your two x values, if we're solving a system of equations, they intersect at ordered pairs. So you need to know what that point is. Okay. Shall we practice on the second one? Got y equals -x squared plus 2x plus 10. Y equals x plus 4. I don't think, nope, it's another class. Okay. Unfortunately, I'm working at the bottom of the screen, so. What are you doing first?
You're getting your value, or you're plugging in your y.
Okay. Basically, they're both y equals equations, aren't they? So set them equal to each other. I don't care which way you do this. Your call, but set them equal to each other. So if I say -x squared plus 2x plus 10 equals x plus 4. Try and stay a step ahead of me if you can. Okay. I have x squareds, I have x's, I have numbers. So I probably want to take that equation and make it equal to 0. In order to make it equal to 0,
You have to subtract your 4 and your x.
okay, if we want to subtract x and subtract 4, so that means I'm going to subtract x and subtract 4 from both sides, because how do I move a positive x? I subtract x. How do I move a positive 4? I subtract 4. So it's still -x squared, 2x minus x, plus x, 10 minus 4, 6, equals 0. Okay. My recommendation, if you want to factor this, assuming it factors, which that's what we want to try, right? And based on what we're doing, these are going to factor today, folks, okay? They're going to factor. What do I not like about this setup? I don't like my negative x squared because I want to be able to factor into x and x. I don't want to have to mess with a negative out there because that totally changes things up. So, how can I get rid of that negative? Okay. So one option is to divide by -1. What's the other option? Multiply by -1. They'll have the same result. And we can do either of these because they are equations. Because if we divide one side by -1, we divide the other side. If we multiply one side by -1, we multiply the other. So I actually usually prefer to multiply by -1. But again, divide by -1. Perfectly fine, just the same. What happens whether you are multiplying or dividing by -1? All my signs change. So this becomes positive x squared minus x minus 6 equals 0. And again, as I said, these should be factoring today. X squared breaks into x and x. I need numbers that multiply to be -6 and add to be -1.
3, 2.
It's got to be a 3-2 combo. One of them has to be negative again. Again, it's the larger number. So I'm going to have an x minus 3 and x plus 2. Set each part equal to 0. X minus 3 equals 0. X plus 2 equals 0. What are your x values? Okay. Positive 3 and negative 2. Because I had to add, on the x minus 3, I had to add 3. On the x plus 2, I had to subtract 2. What do you know about those x values?
You have to plug them back into one of the equations.
Okay, we're going to plug them back in. And right now, what I know about my answers are 3 comma something and -2 comma something. Which fun equation did you guys use?
Y equals x minus x plus 1.
I don't know about you guys, but I'm all for the linear. Y equals x plus 4. So, the first one, y equals 3 plus 4. Ooh, tough math. We got that? Y equals 7. And the other one, y equals
2.
-2 plus 4, which is 2. Okay, guys, you have homework on this tonight. Due when? Tomorrow. Okay, homework tonight, due tomorrow. Now, I'm trying to look real quick. Do me a favor and try it. How many problems do you have? 5.
Oh.
Can you handle 5?
Yes.
The first one, okay, the first one you do have to graph. You actually have to do the graphing. And then all the rest are substitution. So you have 1 like the top, 4 like the bottom. Give it a try, guys. It's lesson 4.9 in Math Excel.